Okay, the question is, how do we find the length of a chord? All right, so first we'll draw the chord by drawing a circle. And the major relevant point in this circle is going to be that central point right there. And then we're going to draw a chord. A chord is any 2 points around the perimeter of a circle. And the widest chord, or the longest chord, is called the diameter of the circle. Okay, and we'll give these points labels, A, B, and C. And you will be provided with 2 pieces of information, maybe, unless you're asked to find it yourself. You'll be provided with the radius measurement. In our problem, the radius is 8. And then you'll be provided with a central angle measurement. That is, the angle formed by the connection between B, A, and C. This central angle right here. And that central angle, B, A, C, in degrees, is given as 42 degrees. And what we're asked to find in these problems is BC, or the length of the chord. Just to highlight what that is, BC is this length right here. That is what we are trying to find. And we're going to use trigonometry. But first, we're going to notice something. The distance between A, the center of the circle, and any point on the perimeter of the circle is the radius. The distance between A, the central point of the circle, and any point around the perimeter of the circle is the radius. So the distance between A and B and A and C is 8. Those are both radii. So we can create this triangle right here. By connecting the dots. This central angle is 42 degrees. So, how do we find that length? Well, here's the solution process. The first thing we're going to do is convert 42 to radians. You don't actually have to do this, and I'll show a solution method at the end that doesn't involve converting to radians. But because we're trying to practice the skill of converting to radians, and because in some cases it's required, we're going to do it here. Once you convert the central angle to radians, you bisect the central angle like that, and you use right triangle trigonometry to find half the chord length. You'll find this piece right here, and then you just multiply that by 2 to find the full chord length. So we'll start with step 1. So this is step 1. Remember what step 1 was. We were going to convert 42 degrees to radians. Now, I'm really big on not remembering anything, or remembering the bare minimum. So if you don't know what 42 degrees is in radians, all you really have to remember is that a circle has 360 degrees, and the same circle has 2 pi radians. That's a proportion. So if 360 degrees is 2 pi radians, in 42 degrees, how many radians are there? And so that's what we're going to solve using a proportion. So we'll substitute x for that question mark, x times 360. It's a cross multiply and divide right here. x times 360 equals 42 times 2 times pi. Okay, so we continue solving for x by dividing both sides by 360. On the left, the 360s cancel out, and you have x equals something. Now, it is important at this point to prime factor 42 and 360 so we don't have to use a calculator, because the other thing we're trying to avoid in these problems is a calculator, except when we're finding a trig calculation. So first, we'll prime factor 42. 42 can be divided by 2. We want to start with the lowest prime factor, so 2 times 21 is 42. Now prime factor 21, which is 3 times 7. Those are both prime numbers, so now we have 2, 3, and 7. I can stick those down here where the 42 was, and then rearrange these terms up here so I've got my 2's together. So down here in the numerator, I can write 2 times 2 times 2 times 3 times 7 times pi. 2 times 2 times 3 times 7 times pi. Now I've got to prime factor 360. Okay, 360, that's 2 times 180, which is 2 times 90, which is 2 times 45, which is 3 times 15, which is 3 times 5. All of those are prime numbers, so we've got 2 times 2 times 2 times 3 times 3 times 5. We'll write all those out into the denominator. 2 times 2 times 2 times 3 times 3 times 5. And now we can cancel out the common factors in the numerator and denominator. So there's 1 pair, 2 pairs, 3 pairs. There's no other common factors, so I'll write what's left as 7 pi over 2 times 3 times 5 over 30. So this is equal to 42 degrees. So this is a radian measurement. These are radians. And these are degrees. All right? And what is this radian measurement? Just so we're clear about it. Let me highlight that. Okay, this radian measurement, 7 pi over 30, radians. You know how you said 42 degrees was this whole angle here? 7 pi over 30 radians is this distance. It is a portion of the perimeter. And I'm not sure that that's often talked about. So 42 degrees represents that central angle. In radians, it represents this portion of the total circumference of the circle, like the arc length right there. Okay? So, now what do we do? Well, we cut this in half. We're going to bisect it. Okay, so 2. We are going to cut the central angle in half. All right. Well, our central angle in radians was 7 pi over 30. So to cut that in half, we just multiply by 1 over 2. And now I have 7 pi over 60. Now this is radians, RAD, which is equal to half the degrees, it's 21 degrees, just so we can kind of keep that in mind. 7 pi over 60 is half the central angle. So this smaller is 7 pi over 60. Okay, so now we're going to use trigonometry. Use trig to find half the chord. What do I mean by that? Well, think about the little triangle that we have here. We have this triangle. I've just clipped it out of the picture from above. Okay, I want to know what that is right there, and I know this angle, and I know this distance. This distance, this hypotenuse, is 8. So 8 is the hypotenuse of this triangle, but this also the radius of that circle. Remember that? This distance was 8. So we're going to keep that in mind. Trigonometry tells us that sine is equal to opposite over hypotenuse. Within the context of this problem, opposite side is half the chord length. Okay, so half the chord length, we'll just rewrite this, and I'll use OPP for opposite. That's half the chord length, and then the hypotenuse here is the radius. Okay, so if I want to find that opposite side, half the chord length, I need to multiply both sides by the radius. Right? Cancels out right here. And what I'm left with is I've got the opposite side equal to the radius times the sine. Okay, so what does that look like mathematically? You'll have OPP equal to R times sine of some angle. We usually put that symbol theta in there. Well, the angle that we want to find R times the sine of is 21 degrees or 7 pi over 60. So this is 7 pi over 60. So what we want to do is plug in R, which is 8, times sine of 7 pi over 60. And this is where the calculator has to come in. If you haven't already done so, clear the memory. You can use any scientific calculator with trigonometric functions on it, but most students are using this graphing calculator from TI. It's a TI 84 Plus C Silver Edition. And once you clear the memory, which you can do by hitting second plus 7 1 2, you hit mode. And what you want to do is, depending on what you're going to plug in to your sine function, you either want to have this thing in radian mode or degree mode. We're going to start with radians, so leave it in radian mode. That's the default selection. Hit second mode to quit, and now we're going to plug in this exact formula. 8 times sine, and then we're going to put in a fraction. Alpha y equals, brings up this little tip menu, and if you hit enter, you get a numerator over denominator 7, and then if you want to put in the pi symbol, hit second, and then this little caret symbol over here will stick the pi symbol in there. Down arrow, put 60 in the denominator. Right arrow 1, close parentheses, hit enter. And you get 2.86694. We'll take this out 3 decimals. So we'll round that third decimal. 2.867. Okay. So remember what this equals. This equals the opposite side. And remember what that equals. That equals half the chord length. So this is 1/2 the chord length. If you were doing this problem using degrees instead of radians, you could have done 8 times sine of half the central angle in degrees, which would be 21. Okay, and so if we put this in degree mode and hit 8 times sine of 21, we get the same thing. Okay, so this doesn't matter which one you're doing. Okay, so if 2.867 is half the chord length, the full chord length must just be twice that. So the full chord length so I guess I should write in step 4, double half the chord. The full chord length is twice what we just got, and what we did was that would be 2 times 8 times sine of 7 pi over 60 radians, which was approximately equal to 2 times 2.867, okay? So 2 times 2.867 is 5.734, and we'll just take it out to a tenths place, 5.7. So that is the full chord length. Go back here, and this whole distance, this height right here, is 5.7, approximately. So BC is approximately 5.7. And that is how you find the distance of a chord. Really, really quickly, If you have your calculator in degree mode and you know the central angle, think about what you're doing. You got a central angle and you've got a radius. So you had a radius of 8 times 2, because you're going to double the central angle, times, wait a minute, let me think of this correctly. So first we're going to take half the central angle. So you've got 42 degrees, take half of it, it's 21. Now, what you're going to do is multiply the radius of 8 times the sine of that central angle, and that gives you half the chord length. Then multiply that times 2. So it's really, really quick once you understand what it is that you're doing. Okay, I hope that was helpful.